Let us take a look at the next data science application domain that we want to discuss in our class. So this one is going to be about the Wineinformatics. The way we are going to introduce in this topic is go through one of my master student, James Palmer's thesis. So let's take a look at his thesis. The title of the thesis indicating multi-target classification and regression in Wineinformatics. So there are several keywords. One of the keywords is, of course, the application domain that we want to talk about Wineinformatics. The other one is the multi-target. That indicates that we want to predict not only the grade, but also the price as well as the region. Since we are looking at 3 different labels to do the prediction, that falls into the category of multi-target. And that's why one of the important things we want to do is the multi-target classification, and plus a smaller but valuable topic or the research area called regression, which means that instead of predicting the category, regression predicts the exact value. So for example, if we want to predict the grade, usually we predict 90 plus or 90 minus. However, in regression, we try to predict, say, 93 as the score of the Y. And therefore, this thesis has many, many interesting topics in Wineinformatics. And of course, let's start with the basic stuff. This is the outline I want to talk with you guys in this video, starting with the introduction, talking about Wineinformatics, and then we will look into the data. So this data used in the thesis is actually much bigger than the Bordeaux wine data set that we are working on. And after that, chapter 3 is about the data mining stuff, indicating the SVM, decision tree, etc. Since we have covered those things in other classes already, I want to just skip that one and leave that for you guys to read the thesis. Chapter 4 is about classifying grade, region, and price plus multi-classification with a hierarchical approach. So this is considered as predicting the multiple labels for the grade, for the region, and for the price, and through a very straightforward hierarchical approach using SVM. So that is the outline that we want to see in this video. Starting with the introduction. Wine was considered as luxury in old days, but now it's much, much more approachable. And the quality of the wine is usually evaluated by 2 different things. One is about the physical chemical properties. The other one is evaluated by the wine experts and provide the sensory tests. This slide gives you an example of both evaluation metrics. The chemical analysis indicating what is the fermentation temperature, what's the percentage of the oak, use of the new French oak, barrel aging, how long does it take, and what is the alcohol value, pH value, acidity, and bottling dates, etc. These are very important aspects to the winemaking process. However, for a consumer perspective, this sensory analysis might be more interesting because these experts drink the wine and evaluate the wine and describe those characteristics that he captured, including ripe and deeply flavored, concentrated, and well-structured, etc. And it also gives you guys some properties of fruity descriptions, such as black cherry, wild berry, and raspberry fruit that's pure and persistent. And you can see that both of them are important. These are the descriptors on the Coastal Brown Pinot Noir Sonoma Coast 2009. So that was an example of looking into the 2 different evaluation matrices. As I mentioned, the wine sensory reviews are usually more interesting, so that we looked the data that we're going to collect is more focusing on the sensory reviews. There are several important magazines or websites that try to provide those kind of valuable reviews. Wine Spectator is one of the most popular one, and that is also the one that we are using. It generates about 16,000 reviews per year. Currently, it has more than 385,000 reviews in their database for their members to access. And for those wines that review, not only they provide the sensory reviews, but also provide a score to summarize, to give a verdict of the wine. So if the wine is receiving a score between 95 and 100, it's considered as classic, indicating it is a great wine. If the wine is between 90 to 94, it's considered as outstanding, a wine of superior character and style. Usually, for the wine that's been evaluated 90 plus, that's considered as an honor. For the wine that's between 85 to 89, indicating they are very good wines, and 80 to 84, indicating they are good. Wines below 80 are usually considered as not so attractive, so that in our data set that we try to collect is actually falling into the category from 80 to 100. Those are the target wines that we want to study in terms of the quality of the wine. So wine sensory reviews, by looking into the example of this, the other wine that we are looking at called Dow's Vintage Port 2011, it has received an exceptional 100 points, indicating this is like a perfect wine. So if we try to read these descriptions carefully, we can see that powerful, refined, and luscious, those are the characteristics of the wine, with a super of dark plum, kirsch, and cassis flavors that are unctuous and long. Show plenty of grip, persistent, a long, full finish, filled with Asian spice and raspberry tart essence, rich and chocolatey. One of the for the ages. And basically, it will also provide how long, what is the best time to drink the wine. So it provides a lot of information here, of course. And for a human, we can read those descriptors and understand somehow how does this wine feels like. However, in order to work with computers, we need to find a way to automatically retrieve the important keywords in these descriptions. And therefore, if you are a human expert, the words that are under the bold indicating these are like attributes describing this wine. Now the question is, how do we make computers to automatically select all of these attributes instead of using human labor to go through that? Remember, in the current database of Wine Spectator, there are more than 385,000 wines. It's impossible for a human to go through that database and pick up the attributes one by one. And therefore, what we have done is that we try to develop something called computational wine wheel, developed based on the concept of NC Noble's wine aroma wheel. For the wine aroma wheel that we showed over here, this is a great tool to work on the fruity flavor notes of the wine, indicating those cherry, woody, blueberry, strawberry, etc. However, this wine wheel does not have the descriptions about the tannins, acidity, body structure, or finish, or even those adjective descriptors such as superb or luscious kind of attributes. And therefore, based on this one, we have developed a more computer-oriented wheels, what we call computational wine wheel, to capture all of those, ideally, attributes to describing the wine. And not only that, we also category of those attributes into 3 categories. You can see there are three different colors over here. We have the red color, which indicating that if we use the aroma wheel, we can capture all of those red descriptors. However, not the blue as well as yellow descriptors. And therefore, by looking into that, we provide three categories of the attributes. Category 1 is non-flavor descriptions, indicating those pure, beauty, wonderful. Those are actually important in terms of this using the computer to determine the grade of the wine. Because obviously, if you have these beautiful, wonderful words inside of the wine descriptions, they are more or less likely to have higher scores compared with the wines that don't have those. Category 2 is non-flavor wine characteristics, indicating tannins, acidity, body, etc. And category 3, which is the red one, are considered as the traditional food and wine flavor characteristics. So if we can do that, or based on our computational wine wheel that we developed, we actually can capture all of those attributes. And once we can capture those attributes, the database that we can form can actually answer a lot of tough questions. For example, what makes wine achieve a 90 plus rating? When we get the data and then train those data sets through a classification model, we can actually build a model. And more importantly, the model we choose to build, as long as it's a white box model, we can explain what makes a wine achieves a 90 plus rating or 90 minus. What are the shared similarities among groups of wine, and what is the suggesting food pairing? This can be done goes through clustering approach. We can cluster the wines into similar clusters and then look into the cluster, provide the food pairing suggesting for each cluster. What characteristics different from the wine of Bordeaux versus Napa? So if we get all the wines from Bordeaux as well as all the wines from Napa, build a classifier, we can determine the wine comes from Bordeaux or from Napa, which are two very different styles of the wine. Another interesting part is talking about the weather. What kind of weather will impact the wine growing process? And therefore, the data set can be used into many interesting wine researches. So we define Wineinformatics as a study that incorporates data science in any wine-related data set, including the wine sensory reviews as well as the physical chemical properties. Of course, if we can have a complete data set, it is very interesting to see how can we, using the physical chemical properties, related to the wine sensory reviews as well. So there's a lot of different things that can be done. The goal of this work, the thesis, is try to use the keywords from the reviews that we retrieved from the computational wine wheel. We want to predict the wine's price, quality, and region. And that is the main idea about this thesis. So data that we collected is from 2006 to 2015. So over 10 years, we have collected more than 100,000 wines for the review. And of course, after the careful process as well as the cleaning for the data pre-processing process, we get about 100,000, a little bit more than 100,000 wines that we want to effectively use. And therefore, if we looked into the data distribution, by using the box plot, you can see the upper one is about the grade. In the grade, you can see most of the wines are falling into the category between 85 to 90. And then there are some outliers that are higher than about 96 points, indicating the distribution of the wine. This figure tells you that most of the wine that we collected among those 100,000 wines, most of them are actually 90 minus. That's why the average is about 88. On top of that, for the price, we also draw a box plot over here. Most of the wine are under $100. And more importantly, majority of the wine are between somewhere like 30 bucks. So the average line over here is about $29. And interestingly, you can see that there's a lot of outliers that can go ranging from 200 bucks to over $1,000 for a bottle. And that is the distribution of the data that we see. In terms of attributes describing each wine, the average number of attributes describing a wine, including those 3 different categories, there are about 13 to 14 attributes. The maximum one is like 29 attributes. The minimum is like 4. So the standard deviation is about 2.77. And that is the distribution of the wines that we are seeing for the data that we collected. So we start with a small, for the computational wine wheel, everything begins with 1 year of the top 100 wine. So we go into the top 100 wine of 2011, handpick all of those 100 wines attributes, and we try to collect all of those attributes, forming a dictionary that has about 635 attributes. However, we notice that many of them are similar yet different. So while we try to look into the attributes that we collect, we realize fresh cut apple, ripe apple, and apple, they are all describing the same kind of attribute, which is apple flavor. However, for a green apple, it tests differently from the apple. So green apple is different from all of these things. And that's why we go through all of those attributes and then try to summarize and then try to find these kind of similarities, group them into the same attribute, while green apple will stand differently. And now the distinct attributes, out of 635 that we collected, we have find many of those can be generalized into the same attribute. So we have go from 635 down to 444. After that, we have applied that computational wine wheel on a data set and then publish our first paper, getting some very good feedbacks. And therefore, we come back to this important process, go through all 10 years of the top 100 wines, and then generate what we call a computational wine wheel 2.0. And that gives us a much higher number of attributes. The distinct attributes go from 635 to about 1800. And then we have normalized those attributes into 985. So it's close to 1,000 distinct attributes. So what we're going to do is that we generate a word cloud indicating what are the more common attributes. So flavors, finishes are more common attributes coming out from our computational wine wheel. Peach, red cherries, etc., plum, fresh, cream. Those are the common attributes that you will be able to expect in the wine data set. And of course, there are some attributes that are less common will not be showed over here. So how do we use that computational wine wheel? Let's look into an example. Saying that this table 2 is a simplified computational wine wheel, has only 6 attributes over here. You can see that for each attributes that we have, we use the original one as the dictionary to map into the wine reviews. In this original computational wine wheel column, you can see berry is normalized as berry, so it's the same. Wild berry is wild berry. Raspberry is raspberry. For the words that if you see firm tannins, that will be normalized into tannins high. Chewy tannins will be normalized into tannins high. If there's a light tannins, it will normalized into tannins low. So you can see that the original column is the one that we have 1,881 attributes over here, and they have been normalized into 985, since there are several things are considered the same thing, so like tannins. So in this example, we have 6 original attributes been normalized into 5 distinct attributes. So the way that we're going to do is that we will scan through the wine reviews, and then we try to map with the longer words. So we're starting, since the highest value of the highest number of words that we have in the original column is 2, so we will start with 2 words over here. So we will start with wild berry, firm tannins, chewy tannins, light tannins, try to map to see if there's any words that are mapping into that. And of course, we will be able to map the wild berry and firm tannins. In that case, we will have those 2 attributes. And after that, we will try to map the one word original attributes, and we will find the raspberry. So that in this case, we will be able to find 3 attributes to describing this wine based on this simplified computational wine wheel. Note that the original computational wine wheel is much bigger. So this is how we describe the wine. Since we have 5 distinct attributes, we will have formed a data set with 5 attributes. Since with the 3 wild berry, firm tannins, and raspberry appeared scanned through the computational wine wheel, so these 3 attributes will end up with 1, indicating they do have these attributes, while berry and low tannins stays 0, indicating they don't have this attribute. And that is how we will be able to use our computational wine wheel to go through the whole data set and then retrieve the information that we need. Here is the distribution of the labels, starting to look into the grades. Since we collect all the wines from 80 to 100, we have actually 4 different categories of the grades. Starting from 80 to 84, 85 to 89, 90 to 94, and you can see the wines that above 95 are much smaller in percentage. For the region-wise, this is the old region versus the New World region. So the region-wise has like 2 different categories. For the price, we don't have this figure because in price, we simply try to find the percentile of each category. So we find that in the middle one, this is about $29, and based on the distribution, we can see half of the wines are lower than $29, another half of the wine are greater than $29.